So now for something completely different. We have lesson 3.6, all about lines in the coordinate plane. We have to do slope-intercept form and standard form and point slope form. This has nothing to do with the polygons, does it? Or does it? Well, let's just take a look to see where we're going for the end of this chapter. So this is lesson 3.6. We will come back to this and fill in all these blanks. But just so you know, after this, we're going to talk about slopes of parallel and perpendicular lines. And the key word there is slope. So pay attention. If slope has eluded you, this lesson is where it's going to solidify. And then the last section in this chapter is constructing parallel and perpendicular lines. That's right, time to get out the compass and the straight edge again. Okay, but that's lesson 3-8. So here we are, back at 3.6, and we're talking about the lines in the coordinate plane. Now, there are three ways that we can analyze lines when we're looking at them on a graph. Now, every time it says coordinate plane, you know what they really mean, right? On a graph. Hey, look, it's a graph. So here's a coordinate plane, no problem there. Now, slope-intercept form, standard form, point slope form. These are three different ways to write the same thing. So, slope-intercept form. This is my personal favorite and the one that I will always and forever default to. And it looks like this. You get the y equals mx plus b. Now, which of these things over here looks like y equals mx plus b? Was it the first thing I underlined, the second thing I underlined, or was it the third thing I underlined? Well, there's only one of them that has y alone on one side of the equal sign. Oh, so that's that one. So here we go. Let's label this. This is the slope-intercept form for this line. So we're just going to write these equations a couple different ways. We'll learn why some of them are used, but just so you know, for the rest of your classes with me, we're going to always use slope-intercept form when we're talking about equations of lines. But you got to know the standard form and the point slope form because those are on SATs and sometimes, okay, maybe they do come in handy. So standard form looks like this. A times x plus, oops, that's a plus b times y equals some other number c. And the a here, that's a number. X, that's really x. B, that stands for a number. And the y is really the y. So every time we're dealing with an x and a y, that means we're actually using these coordinate points. So as you get used to the idea of slope here and the y-intercept here, there will be other things that pop up with these numbers and things that you can fill in for the a and the b and the c when we talk about standard form. And a little tangent for you, standard form, we're going to come into this in pre-calculus a lot when we talk about standard form of a circle or the standard equation of a circle. And no, I'm going to stop with a tangent right there. So we will see standard form for other things like circles and ellipses and hyperbolas and not so much parabolas. But here, this is just the standard form of a line. So this is the real basic starting point. Lastly, point slope form for a non-vertical line will look like this. Y minus y1 equals m times x minus x1. An m. Funny. We used an m in the first one. Yes, the m stands for slope because there it is. They're including a particular point with its coordinates of x1, y1. And the point slope form, you just write that number right in there. Whatever your y value was, whatever your x value was, and the slope. So as soon as you see this, you're going to say, oh, I could simplify that, which is great. And when you simplify it, you'll end up with the point slope form. I said that wrong. You'll end up with the slope-intercept form when you start with point slope and simplify. We'll see that happen in just a minute. Let's finish labeling the graph over here. here is your standard form. And of course, the bottom one would be the point slope. Great. So here are some examples. We want to graph these lines using some intercepts. Intercepts simply means where does it cross the x or y axis. So here we go. They're giving us the x and y intercept, and we're going to graph this equation 5x minus 6y equals 30. Oh, all right. Well, which version is that? Which of these three forms is that? Yeah, standard form. Okay, so standard form, the 5, that would be like our A. This -6, that would be like our B, and the 30, that's the C thing. Okay, great. I'm glad we all agree on that. Now then, we are trying to use the x and y intercept to graph this equation. So that simply means that we're going to go back to our geometry definition of a line. 2 points determine a line. Well, what 2 points? Ready? Here, oops. I'm about to write something that is not the answer, so I'm going to write it out just in case those of you who aren't listening think this is the answer. This is not the answer. I will erase this, but I'm just getting you the idea of 2 points determine a line. So I'm going to cross the x-axis. I'll put it here. Then I'll cross the y-axis. That would be my y-intercept. I'll cross it here. Hey, look, 2 points. Can you draw a line to connect them? Yep, me too. So that's all we're trying to do, is find where does it cross the x-axis, where does it cross the y-axis. Those are called the x-intercept and the y-intercept. As soon as I have those two, bam, I get to draw a line. All right, now let's clear that out and get to the real answer. Here we go. 5x minus 6y equals 30. Well, we want to find the x-intercept. Where does this line cross through the x-axis? Well, you know what? If we're crossing through the x-axis, then I know exactly what the y value is. Not -6, not -4, not -2, but 0. So y equals 0 when I'm finding the x-intercept. So let me substitute in the 0. And so 6 times 0, that's 0. So that means 5x minus nothing equals 30. Okay, so 5x equals 30. Divide both sides by 5, and I get x equals 6. Oh, so the x-intercept is 6. That's interesting. All right, so now I'm looking on the x-axis for the 6. Got it. So there's 1 point. So a point on the line is at 6, 0. Then over here, let's find the y-intercept, shall we? Well, the y-intercept, let me change color. The y-intercept will be somewhere along this line, but the handy thing about knowing that it's a y-intercept is that the x value is now 0. So if I slide back along this line, 6, 4, 2, 0, the y, any of these y-intercepts will have the x coordinate of 0. So I substitute that. 5 times 0, take away 6y equals 30. So 5 times 0, that's 0. Minus 6y equals 30. So now I'm at -6y, still equals 30. Divide both sides by -6. And I get y equals -5. So the y-intercept is -5. Isn't that handy that they drew the graph so that we could pick that value right here? So a point on the line is at 0, -5. So there you go. Plot these 2 points and draw the line that contains them. Well, that's 2 points determine a line. I got it. Hey, did we need to know anything about slope? Nope. All I needed was to draw this line. So maybe we need to practice with the slope a little bit. Okay, here we go. So now, transforming to slope-intercept form. This is just a fancy way to say, get y alone on one side of the equal sign, please. So we're going to transform this equation, and what I'm going to do is get the y alone. Oh, okay. Well, if I'm starting with this equation, let's add 6x to both sides. Add, 6x. And there it is, add 6x. That was the step. Okay, now I've got the 3y equals 6x plus 12, and now I get to divide both sides by 3 because I'm trying to get the y alone. Divide this by 3, divide this by 3. Oh, okay, so the 3's cancel here, leaving me with just a y. 6x divided by 3, that would leave me with 2x. And now 12 divided by 3, yep, 4. Okay, so the y-intercept is 4, and the slope is 2, because after all, here is Mrs. Mitchell's favorite thing in the world, in math class at least, the slope-intercept form, where the thing that's stuck to the x, that is just your slope number. You just read it, and somebody says, what's the slope? You just read whatever that m value is. Here it was 2. And the b, that is the y-intercept. That is the number where the line crosses through the y-axis, somewhere along this up and down axis. So here's x, here's y, here's my y-intercept. Okay, now if we use the y-intercept and the slope, we can draw the rest of the line, right? And hopefully you've done this and you say, Mrs. Mitchell, I got this. So first place you put your pencil down is the y-intercept. Who's heard me say that before? So I put my pen down here. Then what? Then a menu pops up. No. Put my pen down here. Now I do the slope. The slope is the idea of rise divided by run. Whoa, run. So this is your up and your down. This is your over. So if it's a slope of positive 2, that means the same thing as 2 over 1, doesn't it? So I'm going to rise up 2 and I'm going to run over 1. So I always am moving to the right as I travel up or down. So whatever sign this has, positive is up, negative is down, the run is always moving to the right. So from this point, I go up 2, 1, 2, and over 1. So there's my next point. Up 2, over 1. Got it. Hey, do you think you could reverse that and go backwards and down? Oh, sure. Yeah, so if I do the opposite thing in both directions, I go down and backwards, that's okay. I'll let you do that. You're in geometry. I license you for that. Algebra, you're not ready for that yet. So here we go. Now we can connect these points to make another line. Did I figure out where the x-intercept was? Well, it was somewhere. Oh, look at that. Yeah, sure enough. There it is at -2. But calculating that wasn't part of this process. So sometimes I can use the standard form to figure out just the 2 points where I cross the y and the x. Other times I'll use my y-intercept and the slope to figure out where the line goes. And remember, the slope is going to be critical in the next lesson because we're going to talk about parallel and perpendicular slopes. Think about if you've ever learned what the phenomenon is for parallel and perpendicular slopes. Meanwhile, let's practice using the point slope form. So here's the standard form. Y minus y1 equals m, the slope, times x minus x1. So they're telling us that we have a slope of -8 and I have this point, 3, -6. Okay, Well, which one of those is the y value? Right, the -6. So that's what I put in here. Now, wait a minute, Mrs. Mitchell, it already has a negative there. Yes, you're right. But even though this is -6, you have to write the whole thing. So look at that. They even showed you in the simplification y minus -6 turns out to be y plus 6. But I'm getting ahead of myself. So here we go. Here's the slope of -8 and the x value of +3. So x minus 3. So what did we do? We substituted -8 for m, which is the slope, and the coordinates 3, -6 for x1, y1. So now we simplify. Y minus -6, that's y plus 6. And here I've still got -8 times x minus 3. And that's it? Well, yeah, sure. Now, does this help you graph anything? Yeah, no, I agree. But wait a minute, we're just one step away from seeing what the y-intercept will be. So as soon as you get as far as point slope form, take that one last step and get the y alone on one side of the equal sign. What is that going to take? Well, I just have to subtract 6 from here, subtract 6 from here, get some distributive property, and then simplify. Wow. So there are a couple more steps, but you're pretty close to having the slope-intercept form. So let's graph each of these equations now, shall we? I'm so excited because this is slope-intercept form. So the first place I put my pen down will be the -2. If we make, let's do this. Let's go, here's my y-axis, and I'm just going to take a guess here that we'll need an x-axis sort of up high. You could put the axes anywhere you want following these grid lines. That's fine. This is just a suggestion. So if this is my y-axis, I read my y-intercept of -2. So that means my first place that I put the pen down will be at -2. From there, I do the slope. This negative sign, I want you to always make this negative sign sort of stuck to the numerator. That's true of any fraction. The sign in front should be considered as part of the numerator. So now I've got -1 and 2. So this means I go down 1 and over 2. So from this point, first place I put my pencil down, down 1 over 2. Do it again. Down 1 over 2. Do you see a line? Down 1 over 2. Got it. So there it is. There's your line. How about this one? What form is that? Yeah, standard form. Now, the way to graph something, if you're starting with standard form, skip all the algebra of getting the y alone on one side of the equal sign and just go for the intercepts. Go for intercepts. And by that, I mean the x and y. Wow. There we go. X and y intercepts. So if I choose x equal to 0, well, wait a minute, let me put my graph lines in here, my axes. So here's my y, here's my x. So if I choose x equal to 0, that means I can calculate what the y value will be when x was 0. So 0 in here makes this term go away completely, and now I'm at 4y equals -8. Divide both sides by 4, and I get y equals -2. All right, that's good. Now we're going to do the other thing. We're going to say when y is 0, that puts me somewhere on the x-axis. So I'll put in a 0 for the y here, and then I'm at -2x plus 0 equals -8. Divide both sides by -2, and I get that x value equals +4. Oops, did I pick that right? 1, 2, 3, 4. There we go. 2 points determines the line. That's all you needed. And there's your line. How about this one? You know what? That kind of looks like standard form again with an invisible 1 right here. So why don't we get options here. We could talk about the intercepts again and say, well, when x is 0, I get my y value equal to -3. Well, that was pretty easy. And then when y is 0, I get an x value of, let's see, divide both sides by -5, an x value of 3/5. Well, that wasn't so easy. I don't know where 3/5 is going to be in between these little grid boxes. What's another option? Yeah, we could write this in slope-intercept form and get the y alone on one side of the equal sign. That means I'm just going to add the 5x over to the other side and leave the -3 where it was. And now look at that. I can see my slope and my y-intercept. I kind of like that. So let me do that. I'm going to put the axes here for the y. And we'll go, let's see, I'm going to stack the deck here. There we go. So there's my x. So if I'm in slope-intercept form, I can just read the first place to put my pencil down. That's the y-intercept, so that would be down here. And then I do the slope. From this point where I first put my pencil down, I will do up 5 over 1. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. Well, hey, you know, I only needed 2 points to make this line, so let's do that. Now I got a line. Last page. What if they only give you 2 points and you have to write an equation from that? This is such SAT work here. Well, let's do this. Let's have a 2-step process. Find the slope, then stick one of these points into point slope form, and then you can stop when you're in point slope form. Okay, so let's see. This formula for slope. Do you remember what it is? y2 minus y1 over x2 minus x1. Well, ask me if you need help with this. I love doing slope. Now we're just going to go straight to the substitution. So here are my 2 points. Let me label these with, can you see black? I don't know if you'll see black. So this will be my x1, y1. This will be my x2, y2. So what are the values that I get to put in here? Well, the first thing I write is the y2. That was +1. Then I'm going to write my y1. That was -9. Okay. And it's still y2 minus -9. So yes, I have the 2 negatives there. So what have I done? Oh, and let me keep going. Now underneath the 1, I'm going to put the x2. That was -1 right here. And then the x1. That's just substituting into my formula. And that was 4. So I've substituted the 4, -9 for x1, y1, and substituted the -1, 1 for x2, y2. Yep, just like we said. Hey, can you simplify that? 1 minus -9, that's +10. And then on the bottom, 1 minus 4, -1 minus 4, that gets you -5. Now, what did I just say about having negatives in fractions? Yes, I would like you to please think of that as hopping up to the numerator. But either way, I can simplify 10 over 5, that's 2, and there's a single negative sign, so it's got to end up at -2. Okay, so that was the first step of just finding the slope. What's the slope? Slope is -2. Now we can select one of the points and write the equation in point slope form. All right, well, what was point slope form again? Y minus y1 equals slope, or m, times x minus x1. Okay, well, hey, let's just go ahead and use our x1, y1. They've already been pre-labeled for us. So I'll put in the -9 here, the slope of -2, and the x value of 4. So I substituted the -2 for the slope and 4, -9 again for my x1, y1. Simplify that, I get y plus 9, -2 is my slope, and x minus 4 is the point slope form version of that. Okay, 2 more. Write an equation of a line with this is the slope that contains that point. Oh, well, let's see. I got point slope form. Let's go for it. Y minus y1 equals slope times x minus x1. Can you simplify that just a little bit? Yes. So you just say y plus 4 equals -1 times x minus 2. Last one. Write an equation of the line that contains these 2 points. All I get are 2 points? Well, you know what? Let's look at this for a second. Here's my x, here's my y. I go through over 5, up 0. 1, 2, 3, 4, 5. Okay, so there's my 5, 0. And then I also have this point, over 7 and down 3. So this was 5, 6, 7, and now 1, 2, 3. So I'm down here. Okay, so I know this is what the graph is gonna look like. Can you make a prediction about the slope? Yeah, the slope's gonna be negative. That's all I was looking for. Okay, so what are the steps here? Writing an equation of a line when you're given 2 points. First we find the slope, then we substitute into point slope form. So, equation for slope. y2, if I write all these out again, the last thing I write is the -3. Wouldn't you agree? Yes. So that's actually the first number that I write when I go to the slope formula. y2, -3, minus y1 over x2 minus x1. Well, -3 take away nothing, that's -3. And 7 take away 5, that's 2. So here's my slope. Ah, look at that, negative slope. So I'm going down 3, 1, 2, 3, and over 2. 1, 2. Oh, that's just what I did when I graphed them. That's so exciting. All right, so I got a slope. I'm not done. Now I have to put one of these points. Which one? This one or that one? Pick one of them and put it into point slope form. Well, what is point slope form? You write the y, then the subtraction sign, and then pick one of your coordinates. I'm going to pick the one that actually has numbers here. So the y1, that was -3, equals slope, got it? -3 over 2, times x, you just write the x, and a subtraction sign, and then that x value that you had. And there you go. You're all done. For extra credit, rearrange this a little bit, do some distributive property, and make it into slope-intercept form. Let's try spelling these things right. Slope-intercept form. So there's your bonus assignment for your notes, to write this thing in slope-intercept form. Okay, have a good one. See you at the practice homework.